Hello everyone, in this video we're going to talk about how we can transform some graphs of exponential functions. So we've done lots of videos about transformations on this channel. We've transformed linear functions, absolute value functions, quadratic functions, radical functions, even some exponential functions back in chapter 1, or not chapter 1, and Algebra 1. And so same exact transformations. That's why these are so important to learn, is because they work for all these different types of functions. So let's dive into this video and talk specifically about how we can transform some exponential functions. So we have our transformations here on the screen. First one we're going to start off with is a horizontal translation. So horizontal obviously means we're going to be moving left and right. And so a translation is just a shift or a slide. So we just move the graph left and right. Our notation is here, and specifically we want to focus on the variable h. We will see that come back into play for a horizontal translation. So with horizontal, same thing is going to go for a horizontal stretch or shrink. What I usually say in class is that it's kind of opposite of what it looks like, right? If I look over here at this example, I see x minus 4. Well, if I see minus 4, I'm thinking, okay, well, that probably needs to be left, right? Well, actually, it is opposite of what it looks like. Reason being is because we had this negative sign or this subtraction sign in our equation initially. And so for that to be x minus 4, we just plugged in a positive 4, which means we're going to go 4 units to the right. Okay, so just kind of remember it's opposite of what you think, right? So same thing for this one. If I see 5 to the x plus 7, I might think, oh, plus 7, let's go right. Well, think about what it was initially. In order for that to become plus 7, I had to have substituted in a negative 7 for h, right? So it would be like x minus negative 7, and we know that a minus and negative becomes plus, and so that's why we actually go left there, because of the initial h value, which was negative 7. So vertical translation is when we shift up or down, and that is what it looks like. It's a lot easier to understand, and the variable we need to remember here is k. So if I have plus 6, notice how that's not happening to my exponent. It's just outside after it, right? It's not small, right? Like an exponent. It's on the same level as my base. So plus 6, we're going to go up 6. Minus 2, we're going to go down 2. Next is a reflection. That's when we flip our graph over the x or the y-axis. And the most important thing to remember here is a negative, right? We need to have a negative sign in order for us to perform a reflection. And so think about reflection, it's a negative sign. Sometimes a negative sign is referred to as opposite, right? So whatever you're making negative, you're going to reflect over the opposite axis. So here we have negative x, so we reflect over the y-axis. And here we are making f of x, or in this case maybe g of x, or y opposite. So we reflect over the x-axis. Next is horizontal stretch or shrink. So here is when we're going to stretch our graph away or shrink towards the y-axis. And the variable, or not the variable, yes, the variable that we need to remember here is a. A represents a stretch or shrink. Now the placement of a, because notice here on vertical it's also an a, the placement of a is going to tell you whether it's horizontal or vertical. Remember, horizontal is our x values, right? And so if I'm multiplying a directly to x, like we are here with horizontal, then that's going to be horizontal because we are affecting x. If I multiply a on the outside to f of x, that's affecting y, which would be our up and down movement, and so that's vertical. Now, just like horizontal translation, horizontal stretch and shrink are kind of opposite of what we think. Here I have 5 to the 3x, right? So I'm like multiplying x by 3, so I might think, oh, okay, that's a number greater than 1. I should probably stretch this. Well, it's opposite of what we think. It's actually a shrink, and it's by a factor of 1 over a, and so in this case it'd be 1 over 3. The next one is 5 to the x over 3, which would be the same as 5 to the 1/3 x, right? And so we see a 1/3 there, or a divide by 3, we might think shrink, but it's opposite of what we think. It's actually a stretch by 1 over 1/3, which would be 1 divided by 1/3, 1 times 3, so 3. And the last one we need to talk about is a vertical stretch or shrink. So in this case, we're going to stretch away from or towards the x-axis, and like we mentioned a second ago, we still have the variable a, but it's now outside, multiplying to f of x, so it's affecting our y, or our output values. So our two examples here, we have 4 times 5 to the x power, so this is what it looks like, stretch by 4, and then 1/4 times 5 to the x, so that's a shrink by 1/4. Okay, so vertical is what it looks like, a lot easier to understand, very similar to a vertical translation. Okay, so we're going to look at 3 examples here today, 3 a little bit different types of examples. And we're going to start off with example number 1. It says, describe the transformation of f of x equals 1/3 to the x, represented by g of x equals 1/3 to the x minus 5. Notice how I paused a little bit there because it's not to the x minus 5 power. This minus 5 is not up here with the x like that. It is large. It is the same size as my base. So I know it's going to be a vertical translation down 5 units. Okay, so that's what's happening. And now let's actually graph it. So in order to help us graph it, they actually want us to graph both of these functions here. And so I'm going to go ahead and graph in blue, like a navy blue, the original f of x function, so 1/3 to the x, right? Well, we know anything to the 0 power is 1. This would be 1/3, this would be 1/9, this would be 3, and this would be 9. So let's go ahead and plot this. So 0, 1, 1, 1/3, and 1/9, right, for 2, we're just getting closer to the x-axis. -1, 1, 2, 3, and -2, 4, 5, 6, 7, 8, and 9. Okay, so I'm going to go ahead and graph this one. This would be my f of x function, my f of x exponential. All right, and so now we'll go back to red, and essentially what we're going to do is move these 5 points that we just graphed 5 units down, right? That's what we're going to do physically. Algebraically, you could just take the y value or the f of x value and subtract 5. Okay, so I'm going to start from left and work my way to the right. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and this point as well. Okay. Now, before I draw my graph, notice also what has happened. My original graph that I did, f of x equals 1/3 to the x, the asymptote was the x-axis. Well, now we're translating down 5, so we're essentially moving this asymptote down 5 as well. So 1, 2, 3, 4, and 5. So now I have a horizontal asymptote right here. So I'll go ahead and draw that in just so we can visualize that. And so now we can draw our transformed function, knowing that we're going to approach this horizontal line, but not cross it just like that. Okay? So our original function was in blue here. So this was f of x. And then we just graphed g of x right here. Okay? All right, so that's example number 1. Example number 2, we throw in our natural base e here. So we need to remember that natural base e is pretty much like 2.72. Or for this video, we're just going to round to the nearest 10th, 2.7, to graph this one. Okay? So describe the transformation of f of x equals e to the x, represented by g of x equals e to the x plus 2 minus 1, and graph each function. So now we see we have 2 transformations happening. So this plus 2 up here, I see that's going to be a horizontal translation. And remember, horizontal is opposite of what it looks like, so we're going to go left 2 units. Okay, now we're going to say, we could say followed by a vertical translation. This says -1, so down 1 units. So down 1 unit. Okay. All right. So once again, I am going to use this table of values to graph my f of x function e to the x. And so you could use a calculator here and just plug in e to the -2nd, -1st, 0, 1, and 2. Well, we know anything to the 0 power is 1. And now I'm just going to plug in. I know that e is approximately 2.72, so I'm just going to call this 2.7. And then this would be about 7.4. To the -1st would be about 0.4. And to the -2nd would be about 0.1. Okay? So obviously we're going to approximate here with our graph because we're graphing tenths, but we'll do the best we can. It should give us a general idea of the shape of this function. So 0, 1, 1, 1, 2, there's 3, so maybe about right in there. 2, 7.4, 1, 2, 3, 4, 5, 6, 7, so maybe somewhere right around in there. And we know once again that this graph should just approach but not intersect our x-axis. Okay, so something right around there. All right, so now let's switch it up and go into the red. And now essentially we're going to take these 5 points that we've graphed and we're going to move them left 2 and down 1. Now remember what happens when we move down or up. It also moves that asymptote. So instead of the graph approaching the x-axis, it's now going to approach y equals -1. Okay, so we'll change this to our dashed line. And now let's go ahead and move all 5 of our points left 2 and down 1. So 1, 2, and 1. 1, 2, 1. 1, 2, 1. And we know these points would be approaching this new asymptote. Okay, so like right around in here. Okay, so now we have our g of x function here, and then the original that we had was our f of x function. Okay, and that is example 2. All right, for our last example, we actually have 2 separate problems that we're going to do. So for these examples, it says just describe the transformation of f represented by g, and then we're going to graph each function. So if you notice here, we're throwing in some stretches and shrinks along with our translations. So for a, we have f of x equals 2 to the x, and g of x equals 2 to the 2x minus 4. So before we start, let's list our transformation that's happening, just like we did on the previous 2 examples. So notice how we now have an exponent of 2x, and we are subtracting 4. So we know this is going to be a horizontal shrink by, let's actually list our translation first. Horizontal translation right 4. Then we're also going to have a horizontal shrink by a factor of 1/2. Okay, so that's what's happening there. So for our table down here, let's go ahead and graph our f of x function 2 to the x power. So anything to the 0 power is 1, 2 to the first is 2, 2 squared is 4. This would be 1/2 and then 1/4. Okay, so 0, 1, 1, 1, 2, 2, 1, 2, 3, 4. And, we go ahead and do the next one. We know that would be 8, right? 5, 6, 7, and 8, just to give us a better idea. Okay, so we graph this one, doing the best we can. Very good. All right, so now in red here, we're going to do 2 things. So I'm going to go ahead and move these points 4 units to the right, and then we're going to shrink them back closer to the y-axis halfway. Right, that's essentially what's happening. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, 4, 1, 2, 3, 4, and our other point right there. Okay, so now before I draw my curve through there, that we're not done, right? We haven't horizontally shrunk it, we've just moved it to the right 4. And so now let's shrink it back closer to the y-axis, so halfway. So we're at 1, 2, 3, 4, 5, 6, 7. At this point at the top, the x value is 7, so it needs to be at 1, 2, 3, 1, 2, 3 and a half, right? That would be halfway closer. This next point here is 1, 2, 3, 4, 5, 6. So 1, 2, 3 would get it closer to the y-axis halfway. This point would be at 5. This point right here, x value of 5, so it needs to be at 2.5. And then we have next point would be 4, so it needs to be at 2. Next point is 3, so it needs to be at 1.5, so about right in there. And the next one is 2, so it needs to be at 1. Okay, so now we have our graph here. And there we go. Okay, so now notice that we did not shift, we did not translate up or down. So it did not move our asymptote. Okay, so now I'm going to take these points away because that just kind of helped me get to my final graph. And that is what our graph would look like for part A. All right, for part B, now we have f of x equals e to the negative x, and then g of x equals -1/2 times e to the negative x. So we see that the only difference here is this -1/2. So we know that we are going to have a reflection over the x-axis, right? Because we're not making x opposite. It already is opposite. So reflection over the x-axis, and then we're going to have a vertical shrink by a factor of 1/2. Okay. So let's go ahead and graph our original function. We know it's e to the negative x, right? So if we're making x opposite there initially, it's like we're reflecting over the y-axis. So it's just like graphing our natural base function e to the x, but flipping it over the y-axis. Okay, so I am going to use, essentially what we're going to do is if we go back to this graph right here, where we had this table of values, right? Basically, we're going to switch what we have here, okay? Because that would be like making x opposite, right? So -1, instead of 1, 2.7, we'd have -1, 2.7, right? So if we had 1, 2.7, reflecting it over the y-axis would be -1, 2.7, right? So I'm going to kind of go back and forth to fill out this table here. We still know anything to the 0 power is 1. But now this would be 2.7, this would be 7.4, and then we'd have 0.4 and 0.1, okay? All right, and if you kind of got lost on that, just plug it in your calculator and you can go to your table of values on the calculator and check that out. All right, so 0, 1, but now we have -1, 1, 2, 3, so 2.7, maybe like right in there. -2, 1, 2, 3, 4, 5, 6, 7.4. All right, and then these points down here, really close to the x-axis. Okay, so here's our original graph. Kind of missed a couple of those points there, but that's okay. All right, so this is our f of x graph right here for part B. All right, so now we know we want to reflect that over the x-axis, and then we're going to shrink it closer to the x-axis by a factor of 1/2. So I'm going to go ahead and do that reflection. So my 0, 1 point would move here, and then these points would be really close up here. And then for -1, we would have 1, 2, about 2.7 right there, and then -2 at -7.4. So that'd be 1, 2, 3, 4, 5, 6, 7, and 8. So about right there. Okay. Now, before I draw my curve like this, right now I need to shrink those closer to the y-axis, or excuse me, the x-axis, by about half, right? So now it's going to be kind of tough because we do have some decimals here, but we'll just do the best we can, okay? So 7.4, it's pretty close to 7.5, so half of that would be like 3.25. So 1, 2, 3, so maybe somewhere like right in there. 2.7, so let's go maybe about a little more than 1, okay? So like right in here. And then we know this would be at 1/2. And then we're getting close, right? So I'm going to take away the points that we've adjusted so that we don't get confused. And these 2 points that are really close to the x-axis, they're just going to get a little bit closer to the x-axis, but not really by much because everything is so tight there anyways, okay? All right, so now this would be our g of x function, which would be us taking our original f of x function and reflecting over the x-axis and then vertically shrinking it by a factor of 1/2, okay? And that's how you can perform some transformations on exponential functions.